In these slides, we are going to discuss the estimation of total phenolic content by Folin-Ciocalteu method. Here in this we are going to have introduction, FC reagent, what is it, and the principle behind the experiment, reagents used, and the procedure followed by protocol, and the graph plotted, and the calculation followed by the results. So here we are going to study the method of Folin-Ciocalteu reagent, where we are going to subject different extracts of the plant into the FCR method, and we are going to calculate or estimate the total phenolic products present within the extracts. We are not studying the antioxidant activity by DPPH method. That is very different from this estimation of the FCR method. So here we are studying the phenolic content within the different extracts. Those are also the antioxidants present in the plant extracts. So here we are only doing the estimation but not the scavenging. So coming to the next slide, here you know that the phenolics include the simple phenols, phenolic acids and flavonoids and coumarins, and the hydrolyzable form of the phenols and condensed tannins, and further tilbins, lignanes and lignins of the plant kingdom. So these are the derivatives of the phenolic forms or the antioxidant forms of the phenol, where we are going to see within the plant extracts of the plant kingdom. When you are going to see the quantitative determination of polyphenols, it will be hampered by the structure, complexity and diversity. Several methods have used to determine polyphenols in plant extracts. So here by this particular sentence, it is nothing but with the help of the same reagent of the reducing kind or any other form of the reaction, with the help of the same method, there will be the different forms of the studies to study these in antioxidant phenols. So there is no particular method confirmed to study the polyphenols. So here what we are studying, the FCR method, it is the one of the method out of all these methods. In this also, what this procedure we have selected, that is the one of the procedure out of the bunch of the procedures. So further coming to the calorimetric reaction, is the one of the widely used in the UV or visible light spectrophotometric methods, which is easy to perform and rapid and applicable to routine laboratory use and low cost. So here, as it is easy to perform, you can adopt a method, easy method, to calculate or estimate the amount of the phenolic content present in the given sample, and it is applicable routinely in the laboratory uses. Further is polyphenols have become an intense focus because of their health beneficial effects. They occur in variety of vegetables, nuts, seeds, fruits, flowers, bark, beverages, and even some manufactured food as a component of the natural ingredients used. Now here, if you are going to consider the whole plant as the product, where from the flower, fruit or the bark or the shoot, you take any part of the plant, the maximum to the maximum, there will be the presence of the phenolic content. So because of that, the whole plant extracts, especially those or the flowers like kind, seeds like kind, and fruits like kind, or vegetables like kind, those are going to have high amount of the phenols, whereas the other parts of the plant is going to have the quite less compared to these particular parts. But the plant products are going to have, or the extracts are going to show the phenolic content in them. They have been reported to exhibit anti-carcinogenic, anti-atherogenic, anti-ulcer, anti-thrombotic, anti-inflammatory, antimicrobial, immunomodulating, vasodilatory, and analgesic effects. So because of the health benefits which we have mentioned here, these health benefits are going to be curing or to restrict or to arrest these particular medical symptoms. So because of that, these particular polyphenols or the phenols are going to take part in the medicinal value. Now further is polyphenols in plant extracts react with specific redox reagent. Now what the highly used reagent is the Folin-Ciocalteu reagent. Now here how we are going to identify the presence of the polyphenol is the use of the redox reagents, where the polyphenols are the self-reducing substances in presence of the oxidizing agents, that is the redox agent, to form a blue complex that can be quantified by visible light spectrophotometry. As we have discussed here, the use of the UV vis spectrophotometry, the same thing has been mentioned here. So here the quantification will be with the help of the visible light spectrophotometry. Further is this reagent is again called it as the Folin-Ciocalteu reagent, usually used during 19th century for the determination of tyrosine in proteins. So here the reducing nature of the tyrosine, the amino acid reducing nature, where it has been reacted with the FCR reagent, that is the Folin-Ciocalteu reagent. Because of that, this particular reagent has been used in the 19th century to identify this particular tyrosine in proteins. In the next slide, we will discuss Folin-Ciocalteu reagent and its preparation. So Folin-Ciocalteu method is the reaction which is going to give the blue color as the product, which is the chromophore constituted by a phosphotungstic phospho-molybdenum complex. So whatever the product is formed, the chromophore, it is going to be having the complex of these both metal salts, that is the phosphotungstic and phosphomolybdenum. As the maximum absorption of the chromophore depends on the alkaline solution and the concentration of the phenolic compounds. So here, as you are observing that this reaction will take place in the presence of the alkaline solution. So here, depending upon the phenolic compounds concentration, the amount of the absorption is going to increase. But this reagent rapidly decomposes in alkaline solutions, which makes it necessary to use an enormous excess of the reagent to obtain a complete reaction. Decomposition, in the sense it is going to give a particular precipitate kind of the reaction. Because of that, what will happen, the chromophores or the products formed are going to precipitate, giving behind the, so this excess can result in the precipitate and high turbidity, making spectrophotometric analysis impossible. So here high turbidity is also because of the formation of the precipitate, which is not going to settle down. Whatever the remaining of the solution can be red, but because of the turbidity, it is impossible. To solve the problem, Folin and Ciocalteu included lithium salts in the reagent, which prevented the turbidity. So because of the lithium salts, the turbidity has been prevented, in the sense the formation of the more precipitate has been reduced and the clear solution has been seen. The reaction generally provides accurate and specific data for several groups of phenolic compounds, because many compounds change color differently due to differences in the unit mass and reaction kinetics. Now here this is nothing but it is not going to give any different color in the whole. It is nearly to this particular bluish color itself. Somewhere there will be the highly intensified blue, somewhere there will be the light blue, somewhere it will be bluish green. In the same manner it is going to give the colors. To some products it may change to other, but to the maximum phenols or the polyphenols, it is going to give the blue color itself, but differing in its intensity or to some slight change in its bluish color. Now here we have discussed that the Folin-Ciocalteu is the reagent with the phosphotungstic and the phosphomolybdenum compounds. Now here the same Folin-Ciocalteu reagent has been prepared with the different formula, like using the sodium tungstate and sodium molybdate. Now these are the two different compositions which has been used in the preparation of the Folin-Ciocalteu reagent. One is, in one they are going to use the phosphomolybdenum and phosphotungstate. In the other they will use sodium tungstate and sodium molybdate. But here you have to make a note that presence of the tungstate, or these both, tungstate and the molybdate, these both has to be there to take part in the reaction. So further is this one, where they are going to make the Folin-Ciocalteu reagent in this manner. Here is the one which I have discussed, that how it is going to be and how it is going to react and how it is going to give the color to the polyphenols or the phenols or the antioxidants present in the samples or the standard series. In the same manner this is also going to work. Now further, in the next slide, the reagent will react with any reducing substance. So here it is not specifically stick to any product. I mean to say that it is not stick to any one kind of the phenols or the polyphenols or the free phenols. They can react with any of the reducing substances. So here in some research articles they have mentioned that there is a con of this con, in the sense there is the negative point, that the Folin-Ciocalteu reagent can readily react with the reducing sugars present in the sample. So here if you are going to consider this Folin-Ciocalteu reagent is readily going to react with the any reducing biochemical. After reacting it can give the product of that. So further, FCR has shown significant results not only in total phenol content estimation, it is also seen in Lowry protein assay estimation. Further quantification of nitrogen has also been done with the help of this FCR method. As it holds a high significance to measure antioxidant capacity, the reagent has shown trusting results of foods assay and supplements in food science. Now further, when you are going to observe these diagrams, these are the polyphenolic or the phenolic types, that is the flavonols, anthocyanidins, flavontriols, isoflavones, hydroxybenzoic acid, hydroxycinnamic acid, and procyanidins. Further is the principle. Now when you are going to consider in this principle, here again we will discuss only a few points, but principle is very specific and brief, so listen carefully. The total phenolic content of different compounds in the plant was determined by FCR. The reagent will react with the reducing sample and it measures the total reducing capacity of the sample. So here in this point we are seeing the content. Here we are understanding the reducing capacity of the sample in the presence of the FCR. Now further, the Folin-Ciocalteu reagent contains heteropoly-phosphotungstate molybdates. So here these heteropoly-phosphotungstate molybdates are the heteropolyacids, which are the class of acids made up of the combination of hydrogen and oxygen with particular metals and non-metals. Because of this combination of hydrogen and oxygen, there will be the sequence, which will be having this sequence to transfer of the reversible 1 or 2 electrons by reduction reaction. So here you can understand this is what the main mechanism behind the reducing capacity of the reducing samples or the components like the phenols or the polyphenols with the FCR. So here, because of the presence of the particular hydrogen and the oxygen with particular metals and non-metals. So this heteropolyacids is a cluster of the acids. In this there will be the FCR also, Folin-Ciocalteu reagent. Because of this nature of this particular FCR, that is the heteropoly-phosphotungstates molybdates formation, has given the sequence of transfer of reversible 1 or 2 electrons by reduction reaction between the reducing component and the FCR. So here you can see, after this will be the phenol. After subjecting this with the FCR, it is going to show this H minus, H plus. So there will be the reduction of the component in presence of the phenol. So this will be the final bluish compound. Now further, FCR reaction in alkaline medium with phenolic compounds will form a blue color complex. So here this blue color complex is going to give certainly this end product and its formula. Further, proposed that molybdenum is easily reduced in the complex and electron transfer reaction occurs between reductions phenolic and molybdenum in FCR. Now when you are going to observe these two reactions, this is the reaction of phosphotungstate and phosphomolybdate form of the composition of the FCR, that is the Folin-Ciocalteu reagent, where it has been given this. In this, the molybdenum is going to get transfer the electron to give the blue color to the reducing component or in the sample. Now further, in this also it is the sodium tungstate and sodium molybdenum complex. They are the FCR reagent. Here also the molybdenum is going to readily give the electron transfer, and it is going to be reversible between the reducing component or the sample and the FCR. So further is the point, the maximum absorption depends on the concentration of the phenolic compound in sample. Now here, when we are going to subject the phenolic compound with the FCR, it has to react. Whatever the amount of the FCR we are using, that will be high compared to the whatever the phenolic compound is present within the sample which we have taken. In the sense that whatever the phenolic content will be present, it has to get reacted with the FCR. So it is directly proportional that phenolic compound concentration is going to give the color after the reaction, so it is going to give the particular maximum absorption. So further is the reduced Folin-Ciocalteu reagent is detectable with a spectrophotometry in the range of 690 to 710 nanometer, and also 730, 738 and 750, 760, 765. So here, why I have mentioned these different ranges, in the sense that I have gone through many research papers and also many lab manuals where they have given the different range of absorption in nanometers. That is, these are a few which is randomly selected, frequently observed within the papers. So because of these are not specific to any specific phenol also, they are used is randomly in this nanometers or the absorption range. So here these are the range of the nanometers for the absorbance has been mentioned, so that further in future if you come across any other article or the book, you should not get confused. Further is that phenolic compounds react with FCR only under basic conditions, where they will use the buffer of sodium carbonate solution at pH 10. The reaction temperature has been used to reduce the time necessary to attain the maximum color. So here this is very important point. this first point you have understood, where I have already spoken in the introduction of the Folin-Ciocalteu reagent, where the alkaline medium is very important for the reaction of the FCR with the reducing components. Now here are the phenols. Now here the reaction temperature has been used to reduce the amount of the time taken to complete the reaction. Here in certain papers and also in certain kits provided to perform these FCR reagents for the lab and also for the colleges, it has been seen that without the use of the reaction temperature, which will be mentioned in the kits, it is going to lead to about 120 to 180 minutes for the completion of the reaction. If you are going to use this particular reaction temperature, whatever, if it is mentioned like 25 degrees centigrade, 37 degrees centigrade as mentioned here, and also in some papers and some procedures they are mentioned to be as the 40 degrees centigrade. That is the maximally seen in every paper and the manuals, that 40 degrees centigrade is the maximum temperature used. So because of that, what will happen, that time is going to reduce to 15 to 20 minutes, but depending upon the amount of the sample you are using. Now further is the Folin-Ciocalteu reagent is not specific and detects all phenolic groups found in extracts, including those found in the extractable proteins. Now here, if there are the proteins which are the complex formed with the phenolic groups, in that also the FCR is going to detect the phenolic group. So because of this nature, it is giving the interesting kind of the result that the phenols, whatever the amount of the phenols present in the samples, is going to be detectable and estimated. So this is regarding the principle for this particular estimation of total phenolic content by Folin-Ciocalteu method. Now here you can see that this reaction, here you can see that this will be the phenolic compound reacting with the Folin reagent, and it is going to get reduced. Here it is giving the particular blue complex. This is the reaction is going to take place, and this one you have seen already in the title page. Now you can see that due to the presence of the more amount of the phenolic compound within the liquids after the reaction, so there is the increment of the color intensity, which is directly proportional to the amount of the phenolic content present in the sample. Now here you can see that these are the polyphenolic or the phenolic components, which we have already seen in the previous slides. So here also the same with a few in extra. So these are the extra structures. Now after this slide we will discuss the reagent. Now we can extract the sample, where we are going to take dried plant material, where you can take approximately as per your wish. We have mentioned here 10 grams. From each sample was used for the preparation of extract, whatever the sample is made. Samples were extracted with 75 ml ethanol, which is 95% volume by volume. So ethanol should be of 95%, which will be prepared of 75 ml volume at 40 degrees centigrade for 10 minutes. So here at 40 degrees centigrade we are going to extract by applying a procedure. So further the extraction process was repeated thrice. The solvent was evaporated at 40 degrees centigrade under a reduced pressure. The dried extract was used for further analysis. Now this is how we are going to do the raw extract, where in the raw extract we are going to subject the material to the ethanol, and further we are going to subjected solution to 40 degrees centigrade further. So that is again called it to as the heat washed extract. Heat washed extract means here we have subjected the raw extract to the temperature or boiling at 40 degrees centigrade, not exceeding to that. Further is that after doing this particular preparation repeatedly, we are going to collect enough amount of the sample, and further this sample will be taken and we are going to measure it or weigh it, and further we are going to dissolve it in the methanol. Here we have used 10 milligram and we have dissolved in 5 ml methanol, and further we are going to do sonicated ultra for 45 minutes at 40 degree centigrade. Here we are using a kind of the technology where we are going to do ultra vibrations. So because of that, the dissolving of the sample is going to be very early. Now further we are going to do it at 40 degree centigrade. Again here also we are dissolving the sample in methanol at 40 degree centigrade, but for the longer time, for 45 minutes, followed by centrifugation, which will be at 1000 into G, that is the at for 10 minutes. So here the clear supernatant was collected and stored in a amber bottle for analysis. Now after doing this repeatedly, the enough amount of the sample which we are required to perform the experiment that we have to collect. Now further we are going to prepare FCR reagent. 2 ml of FCR reagent was taken in a beaker and distilled water was added to 10 times dilution. Take the 2 ml and we are going to make up the volume to 20 ml, so there will be the 10 times dilution. So further we are going to prepare the sodium carbonate solution at pH 10, so this will be the composition, and further we are going to have prepared the diluents which are necessary if there is the requirement in the procedure. One diluent will be distilled water and the other diluent will be the sodium carbonate, which will be this particular sodium carbonate at pH 10. So further is the preparation of standard gallic acid solution, where this 5 milligrams of gallic acid was dissolved into 10 ml ethanol and make up to 100 ml with distilled water. So the concentration of the solution will be of 50 microgram per ml. Then with the help of this we are going to prepare the standard series during the procedure to perform the experiment. Now further is the preparation of the blank. You know, as usually the blank will be other than the sample and the standard stock solution. So blank consists of the 5 ml Folin-Ciocalteu reagent. This 5 ml is the Folin-Ciocalteu reagent. 1 ml is the ethanol or the methanol, any of that, but if you use methanol it will be good because in the sample you are using the methanol, and 4 ml of sodium carbonate solution. So this is regarding the blank. Next is the procedure. As procedure is the same as the protocol what we have mentioned here, so we are going to discuss the protocol directly so we can understand the procedure and protocol together. Now further is that we are going to take the volumetric flasks for the appropriate volume which we are going to get at the end of the or within the mid of the experiment. So as we are going to use the samples or the standard series high in the amount of the volume, and also further the what we call reagent and also the buffer in high in the volume, we are going to take the volumetric flasks of around 50 ml. with the standard marking. Now when you are going to take the volumetric flasks, we are going to take for blank and also for 6 standard series solutions and for the 2 samples. So there will be the 9 volumetric flasks, and further we are going to take the gallic acid, the standard stock which we have prepared already. We are going to take the gallic acid in mls. Blank will get 0 ml of gallic acid, whereas standard series is going to get the gallic acid as mentioned here, 1 2 3 5 7 10, and further the 2 samples where each is going to be 1 ml is going to be taken, where these are the unknown given solutions for the concentration of the phenol components. Now further is the amount of gallic acid, which we have already mentioned, that with each ml of the gallic acid there will be the increment of the 50 microgram of the gallic acid per ml. So for the first it will be the 50, 10, 150, and for the fourth it will be 250 and 350 and 500. So here this is the amount of the gallic acid in the standard series, and here also we can see this, as these are the unknown samples, given samples for the estimation of the phenol. There is no mentioning of the amount of the phenol amount. So further is the adding of 5 ml of Folin-Ciocalteu reagent to each test tube, including the blank. So to all the test tubes we are going to add the Folin-Ciocalteu reagent. Now further you are going to add 5 ml of 7.5% sodium carbonate solution of pH 10 to each test tubes. Now here we are going to add the other than Folin-Ciocalteu reagent, the sodium carbonate of 5 ml to each test tube, and further we are going to incubate under incubator for 25 degrees centigrade or 40 degrees centigrade. In some papers and some lab manuals it is mentioned 40 degrees centigrade. So approximately you can use any temperature depending upon your requirement. So here we have used 25 degrees centigrade, but for the knowledge sake we have mentioned 25 or 40 degrees centigrade. It has to be for 20 minutes. Now further, after this you are going to take the test tubes which are to be the equal in number to this particular volumetric flasks, that is 9 number of the test tubes, and you are going to mark as similar to this, that is from blank to standard series of 6 test tubes, and further the samples. So to all the test tubes with their respective containers, previous containers of volumetric flasks, you are going to transfer 2 ml of the liquid. So you are going to make the similar serial of the test tubes as similar to the volumetric flask. After that, after taking 2 ml in each, so here you have to be very careful that during this transfer of 2 ml from each volumetric flask of 2 ml of this particular solution to the new container, the test tubes, you have to use the separate the pipettes or the whatever the micro tips for your micro pipettes. So it all depends on you, that even you can take less volume also, so that you can make the experiment very simple. But here we have done this, so we are discussing the same. So further is that you are going to make up the volume of test tubes to 5 ml with distilled water. So these test tubes we are going to make up the volume with the distilled water, and further after that we are going to mix components very well, and further we are going to take this sample from blank to the standard series and the samples into the cuvette, and we are going to measure the absorbance at 760 nanometer with UV spectrophotometer. Now here, before to absorbance of the samples and the standard series under blank fixed, we are going to keep the cuvettes, all 9 cuvettes, for standby in the stand for 15 minutes, so that the solution has to get settled. So after that, if you are going to take the absorbance will be the very exact measurement. So whatever you got, you are going to mention here in this particular protocol, and further you are going to plot the graph. Now we are going to take the whatever the amount of the gallic acid has been mentioned, and also the whatever the amount of the absorbance we got respective to the gallic acid amount, and we are going to plot a scattered graph where you are going to get these dot data labels, and you are going to run the trend line or the linear regression line, where both the names refer to the same, trend line and the linear regression, and you are going to get the values here. And further you are going to subject these values in the formula, which we are going to discuss further. Now here, before to that, you are going to understand the absorbance and the OD values will be on the scale of the y-axis. Y-axis is going to have the scale, where according to that, whatever the absorbances we got here for the gallic acid is going to be get plotted, and for the x-axis there will be the concentration of the gallic acid in micrograms. So here the y-axis is always dependent on the x-axis, as we have discussed in the different experiments also. Now here further, when you are going to consider the samples T1 and T2, these are the absorbances, which is going to be 0.229 and 0.227. So here, as they both are nearer to each other, we are going to consider only one, that is the 0.229, which is highest. So when you are going to calculate, this calculation shows that the absorbance was plotted against the standard volume. Now further, that we will discuss in the formula. The regression line to this graph is used to determine the polyphenolic equivalence in the various samples to be analyzed. That how much the polyphenol is present, that is going to be measured. The regression line y is equal to mx plus b from the standard curve was used to determine the polyphenolic concentration of the pure compounds. Now you see that y is equal to mx plus b. When you are going to consider here this particular value, what we got after developing the trend line or the linear regression line, that is y is equal to mx plus b. So here m has got the value, x remains the x variable. It is going to remain as the x variable only. Here m is 0.001, x is x, the variable remains the same, and further is the b plus b 0.018. So here the same has been mentioned here, y is equal to 0.001x plus 0.018. Now further, when you are going to take the description of this particular formula, y is equal to mx plus b, it is going to show y is equal to absorbance, m is equal to gradient, and x is equal to concentration. So here x is equal to concentration of the unknown. So we are going to calculate the concentration of the unknown, and we got the value of Y already, the absorbance, that is 0.229. Further is the M gradient. M is equal to 0.001, which is here. So as per the, it is going to correspond to the formula 0.001, and further B 0.018 corresponding to the formula. This is the value. So here further you are going to subject the values into the formula. Before to that you are going to make the modulation in the formula that to calculate the concentration of the unknown, so that the x is equal to y minus of b. X is equal to y minus of b divided by m. So further, when you are going to subject the values, x is equal to 0.229 minus 0.18 divided by 0.001, and the whatever the result we got, it is 211 micrograms per ml of the whatever the phenol is present in the extract. So if you are going to convert it, it is going to be 0.211 milligrams per ml. Now here, initially during the preparation of the reagents, we have discussed that 10 milligrams of the sample extract which has been taken and dissolved in 5 ml of methanol. Therefore, each ml is going to have 2 milligrams of extract in each 1 ml of methanol extract solution. So when you are going to consider polyphenols amount in milligram per gram, so here we are going to do the calculation for the polyphenol of the milligram, this one, where it is going to be present in the gram. Whatever the extract we taken is in the grams. If it is also taken in the milligrams, if we convert it to the grams, so that extract remains the extract weight itself or volume itself. So within that we got this particular mcg per ml. So we are going to do the calculation like 0.211 divided by 2 into 1000. This here 0.211 is the whatever the milligram we got per ml, divided by 2 is that each ml of the methanol had the 2 milligrams of the extract. So while dividing by 2, it is going to divide this 0.211 for each ml. For each ml, how much of the milligram, how much of the phenol is present, that is going to show. So further, that each ml has been multiplied by this 1000. This 1000 is of that milligrams in 1 gram is 1000 milligrams. So it is nothing but 1 gram is going to have 1000 milligrams. So when you are going to multiply, that is going to give 105.5 milligrams of the phenol extract, which is present in the gram of methanol extract sample. Now further, this is the one kind of the formula used to analyze the phenol. I have also gone through the similar y is equal to mx plus b formula has been taken in this manner, where x is equal to y plus b divided by m, where the same values will be subjected and the value of the milligram of the phenol per gram is going to differ, that is 123.5 milligram per gram of methanol extract has been present in the methanol extract sample. So here these formulas or the way of calculation has been taken from the very well published journals itself, not from any lab manual of colleges. So apart from this, there are many methods within the FCR itself where they are used to analyze the presence of the phenol compounds in the plant extracts. of any part of the plant. So we can discuss the enormous amount of the calculating methods and also the enormous amount of the phenolic extraction methods to perform this particular calorimetric method itself. Apart from this, there are other thin layer chromatographic methods for the estimation of the polyphenols and phenols also. So here what I want to say is that as mentioned, for the calorimetric kind of the methods, Folin-Ciocalteu reagent method is the best one, and also it has to be a particular specific method of calculation where it is going to be considered universally to make it very confident to get the results in the appropriate track than getting the things something like choice kind. So I hope I have given the much information which is required for the understanding of the estimation of the total phenolic content by Folin-Ciocalteu method. So if you have come across any wrong explanation or any different than what you are expected, you can comment below in the comment box of this video. And also for the antioxidant activity of the by the DPPH method, you can go through our already uploaded video slides which has been prepared in the similar manner how it has been prepared for the Folin-Ciocalteu, and many have been appreciated us by that particular video log. So you can go through that also, and also different experiments. And also I request to subscribe to our channel and help us and encourage us and share our channel, and request your colleagues or friends or students to subscribe to our channel so that we can give you the fast way of the video logs so that you can get more information. And we try our best to put across in the explanation manner where we are collecting the information and also we are giving that information at your desk or on your desktop or laptop or on your Android mobiles or any other high-end mobiles you are using. Thank you for watching this particular video, and also be tuned to Big Book. Definitely we will come with good content if you are going to encourage us by subscriptions and also sharing and distributing these contents. Thank you very much.